UPSC Engineering Services 2018 Prelims Mechanical Engineering Set A 150 meter diameter shaft rotates at 15,000 rpm 1500 rpm within a 200 long general bearing with 150.5 internal diameter. The uniform angular space between the shaft and the bearing is filled with the oil of dynamic viscosity 0.8 poise. The shear stress on the shaft will be, so we want to create here the shear stress of the shaft. So for creating the shear stress of the shaft, we need the formula tau equal to mu du by dy. Tau is equal to mu du by dy. So here tau is du is equal to change of speed, means that will be r1 omega, and dy is equal to changing distance, so that is the r0 to r1, means radius will be changed there, that is the r0 to r1. So here mu is equal to dynamic viscosity, so mu is equal to dynamic viscosity, that is 0.08 poise. So that is the poise. So poise is poise is equal to 10 to the power minus 1. So poise will be converted to 10 to the power minus 1. So that will be 0.8. That will be 0.08. And after that, there is the R1, means first the diameter. That is the R1 is there is the R1. The diameter is 150 diameter. 150 diameter means radius will be half of that, that is the 75 75 that would be converted into meter, that is the 10 to the power minus 3 meter. So 0.075. Then after that, there is the r omega. R is equal to 2 pi. R1 is there. Then omega is equal to 2 pi n divided by 60. So omega is equal to 2 pi n divided by 60. So 2 into pi. The n, value of the n means number of rotation. So that is rpm 1500 divided by 60. And then r0 minus r1. So r0 minus r1. So 150 is outer diameter, and 150.5 is the internal diameter of the shaft. So minus of that into 10 to the power minus 3. So there is the 0.25 into 10 to the power minus 3. So division of this, we will get the answer of that. So this is the concept of this is the question answer of that tau will be, that is the shear stress. So this answer is fine. Second question is which one of the following substance has consist specific heat at all pressure and temperature? So which one of the following substance, question number 2 is which one of the following substance has constant specific heat at all pressures and temperature? So monoatomic gas having only constant specific heat, like diatomic don't have the constant specific heat, triatomic gas also don't have the constant specific heat, and polyatomic gas also don't have the constant specific heat. Only monoatomic gas having the constant specific heat. So that this is the correct answer. So what was the question? Which one of the following substance has the constant specific heat at all pressure and the temperature? So only the monoatomic gas having the constant specific heat. Question number 3. The prediction of the kinetic theory of the ideal gases very well with the experimental result for the real monoatomic gases. Question number 3. The shear stress tau for steady fully developed flow inside a uniform horizontal pipe with coefficient of the friction F, density rho and viscosity nu is given by. So what is the formula? F rho nu square divided by 2. F rho nu square divided by 2. This is the formula of the shear stress. So what is the shear stress formula? That is the F rho nu square divided by 2. This is the shear stress formula. The shear stress tau for steady fully developed flow inside of the uniform horizontal pipe with the coefficient of the friction F, density rho and viscosity nu. So given by F rho nu square divided by 2. This is the exact formula of the shear stress tau. When the friction is F, density is nu and viscosity density is rho and viscosity is nu. The shear stress at wall tau is given by tau is equal to F dash by 2 the rho nu square. So F dash is the fanning friction coefficient. F dash is the fanning friction coefficient. The above equation definition of the fanning friction. Above is the definition of the fanning friction coefficient. So this was the three questions, and we have given the answer of that. That's it.